The last thing we need to tackle in 2.4 is our measurements for spread. First thing I do is have this series of histograms showing final scores for my statistics classes from Cuyamaca, Miramar, and Mesa one semester when I taught at all three schools, and I taught them all statistics using the same tests. So should have been fairly similar distributions across the classes, and we can see we don't have that. If you look, one thing you may notice, each of these particular schools, I kind of consider anybody scoring below 40% as somebody who gave up well before the final exam. If a student is working hard in the class, they're guaranteed to do more than a 40%. So all of these students are students who, just sort of gave up sometime probably right after the W deadline. Especially these students, if you look, we have 2 students here who scored between a 10% and a 20% in the class, which essentially means they did no work at all. So you can kind of think maybe we should be able to throw out these students who are very, very unusual, at least those very, very low outliers. And then you could talk about the spread. Once you throw out this one very low outlier at Cuyamaca, we don't have a whole lot of spread, right? Most of our all the rest of the students are in the low F to A range. At Mesa and Miramar, there's a lot more variability. Even once we get rid of that person scoring between a 10 and 20, there's still people scoring in the 20% range. So it takes a lot more of this sort of like, well, maybe these people also didn't try. Maybe these people also didn't try before we can kind of see something reasonable looking. But none of these really tell a very good story about spread. But spread was a big issue when we were doing our drawings or our activity on Tuesday. Certain groups had very little spread, right? Those people who were doing siblings or number of pets had a lot less spread than those groups dealing with rent, right? They had a lot larger spread. So the spread, our mins and our maxes, really helped us figure out what our variables were. So in terms of our measurements that we could use, if we have a data set to look at our spread, the most basic of those is the range. The range is the basic bitch of spread. And in this case, it's just max minus min. It's very silly, right? Like I said in class, it's more efficient to just report out your min and your max and have people be able to think about the range on their own than it is to report out the range itself. So this is sort of like the mode. It is very useful when we're looking at a histogram, and that's the best we can do. But otherwise, when we have a true data set, range is never going to be the way we look at our spread. Instead, we're going to use one of the next 2 measures of range. First is the IQR. It's the interquartile range. This is the range of the middle 50% of our data. So as I sort of drew out in class, first thing you're going to do is find these quartiles, and what those quartiles do is they divide our data up into quarters. So if we have a median dividing our data in half, Q1 divides it so that we have 25% between the min and that, 25% between the Q1 and the median, and Q3 does the same thing with the max, 25% to either side of that Q3. Q3. So when we're talking about our IQR, that's going to be Q1 up to Q3. I had to go. My cat is making all sorts of noise. I ran off because my cat was playing with a giant yarn ball with like a bell inside of it. And as soon as I ran and got my camera, she stopped. So she sucks. Anyways, where was I? Oh, yes. So the range from our Q1 to our Q3, this is what our IQR is, this distance. The range would have been the entire distance from your max to your min. So we have some information here about finding quartiles. We did this in class. I'm going to run through how that little location or position formula could help you with some really simple data sets. So in this particular example, we have 10 different objects. If we want to look at where the median is, we could do that median position formula, which is 10 plus 1 over 2, 5.5. So we'd find out our median is somewhere between 50 and 60, which means we have 5 in either half. And then we could use the position formula again. I know it's completely silly here. If we have both halves, we can immediately see there's the median of our lower half, there's the median of our upper half. But if it was a larger data set and you were doing this by hand, you do have the ability to still use that position formula just with that new number that we have. So 5 plus 1 over 2 means that we need the third thing. So 1, 2, oh, the 30 I already circled. And counting for the Q3, just count back from the maximum to find your Q3. So once you find your Q1, which we said was 30, the median of that lower half, and our Q3, which is 80, your IQR is just going to be Q3 minus Q1, just like your max minus your min, which is 80 minus 30, or 50. This is the one thing that you may want to have on, ooh, that's a huge pen. I did not want that. This is the one thing that you may want to have on your note card. So we do get a note card for the exam. And any sort of formula that you want to have, it's definitely something you want to put on that note card. So if it's an odd number, we talked about this in class. So in this case, there's only 9 items. The median is right there in the data set. There are 2 ways to handle it. Like I said in class, my favorite way is the way that the calculator does, which is to exclude the median in your halves. So when you look at the halves, you're only going to think there are 4 in each half. There is also that way where you can go ahead and include the median in both halves, putting 5 in both the upper and lower half. If you did your position formula here, 4 plus 1 over 2 would give you 2.5. So our Q and our Q3 are between 2 numbers. So for Q1, we're going to have to average 20 and 30, figure out what's between them. And for Q3, we're going to have to do the same thing with 70 and 80, which is 75. So our IQR is equal to Q3 minus Q1, 75 minus 25, also still 50. So if we had done the other method, what we would have had, just to throw it out there, is we would have looked at this is all 1/2. So when we're looking at this half, we would have gone, oh, the Q1 is 30. And then we would have taken that away and we would have looked at the upper half. Oh my God, this is slower than I expected. We would have looked at the upper half and we got, oh, it's 70. And 70 minus 30 is 40, not 50, which actually does make a big difference when it comes time for us to do something like a box plot, which we're going to learn in the next video. So this difference between how the calculator does things and how StatCrunch does things, this method where we include versus exclude, makes a big difference. So we did 2.4.1 in class, so I am not going to do it. I will, of course, star up the most important thing here, which is that property. The IQR is not influenced by outliers. If you look back at this data set, I can change this to 9,000. It's not going to change anything about the IQR because the IQR is still going to fall exactly where it was for Q1 and Q3. So outliers are not an issue because we're ignoring the upper 25 and the lower 25% and not including them at all in this measurement. Therefore, it's going to be our best measure whenever we're dealing with our ugly data. Okay, so let's do one more, I guess, or 2 more examples of trying this out. Again, as always, here's your chance to pause the video and try this on your own and come back and see if you got it right. If you're coming back, you should have found your median. You could have entered all these things into your calculator list. They are already in order and are structured in a way where the calculator list is totally unnecessary. So it's faster to do by hand. We can see that all of our data is even. The middle 2 values are 7.2 and 7.3. So we're just going to add them together and average them. Our first and third quartiles, well, again, it's divided in half already. So all we need to do is figure out where the middle of each half is. And I'll just count it off. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13 things in each half, which means I'm looking for the 7th. So 1, 2, 3, 4, 5, 6, 7. There's our middle number, Iowa and Ohio. So Q1 is Iowa at 6.8. Q3 is Ohio at 10.5. And then our last step here, it says, let's find our IQR, which is still Q3 minus Q1. I will write that out every time I do it. because it's just getting that sort of cemented in my head. That way on a test, if for some reason it's not on my note card, I know it. All right, we have one more example of this IQR, and it's a tough one. So what about doing this with a histogram? So now we have a histogram with 44 calls in it. We can see we have the length of the calls here, and we're trying to find the intervals for certain quartiles. This is a lot more challenging. If you're up for that challenge, I suggest pausing, seeing if you can figure out how this would work. Otherwise, I'm going to walk you through this. So first thing you need to do is, or first thing I'm going to tell you is how people do this wrong, is they sort of just go, okay, here's 1, 2, they kind of like do this thing. Here, this is where the median is, right? It's the middle one. But that implies that every single bar is even. And there's a hell of a lot more. There's 13 different calls in that first bar and only 1 in the last bar. So those are not even. I cannot just X them off like that. So that's not fair. So what am I supposed to do instead? Well, one option is to use that median location formula, right? So if you use the median location formula, 44 plus 1 over 2, well, that tells us that we are looking for the 22.5. We're trying to figure out where the 22nd and 23rd longest phone call are so we can average them. So if we count over, well, there are 13 phone calls in the first bar, so it's not there. There's another 2 in the second bar. So now we have 15 phone calls. And then, what have we got in the last? 9. So here we're at 15, 9, that takes us to 24. So that 22nd and 23rd are going to fall here. This is where our median is. If that doesn't make sense to you, a way to make it a little more visual is to go ahead and divide up each of these into the bars for each observation. Sort of like a lot of the groups, I had a couple groups that just sort of stacked up observations in the first class because we had little strips. Oh my God, is that 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool. And then you can actually count off to the 22nd. So, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23. These are the 2. We don't know exactly what they are, so the best we can do is say that this is somewhere between 16, and it looks like we're counting by 8s, 16 and 24 minutes is the length of the call. So hopefully that makes some sense. It's much easier to just add, but this gives you a visual way to sort of count it over. Now, Q1 and Q3, equally difficult. Now we need to think about how many are in each half. So if there are 44 calls, that means there are 22 calls in each half of our data set, right? So we can do the same location formula, figure out that we need to find the 11th and 12th, and then do the same game. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12 are both here, meaning that this is where Q1 lives, right? Q1 is somewhere in there, somewhere between 0 and 8 minutes. I do want to point out that I notice, or what something gets students confused, is that our position for this one was 22.5, and 22.5 happens to fall inside that interval. That is just a coincidence, right? Its position is 22.5. We had to count over. Here, the 12th and 13th, that doesn't fall inside 0 to 8. So it's literally just a location. It doesn't tell, a position doesn't tell us where or how long these phone calls were. So if you felt, if you didn't pause before, pause now and try to figure out where Q3 would be using the same logic. So finding Q3, we're going to have to do the same kind of thing. Here's 8, 6, and 5. Except for we're moving from the high end over. So 1 isn't enough. Another 8 means that we've gotten the 9 longest calls. And we need the 11th and 12th, right? So not enough. So Q3 has to be here because that would take us to the 15th. So between the 10th and 15th are going to end up there between 32 and 40 minutes.